So, as I see few people who are not Polish speaking, I will dare to say it in English. So the presentation is called What is Code? There was a in-depth discussion whether I'll be singing at the introduction, and Schultz hinted me that there is a very profound comic sketch, sitcom, about what is code and what is laugh and everything related to that. However, I will cover something else than singing. I would like to ponder a bit, because again, it appears to be a little bit meta presentation, to ponder about everything that we have on the project, but it is not. Just close the door. Cheers. About everything we have in the project, but we don't exactly treat it as source code. So I'll ponder a bit about what we actually do in the project and whether code we are writing is everything, because we see it isn't. Because there is a business side of the project. There are guys at the operations, which we show our code to the other side of the wall. There are testers, especially in the tester-driven development environments. And it appears that it will not be a soft skills talk. I will tackle those three areas, like business, documentation, operations, and testers, and see what are the tools that we are using there, and whether those particular tooling really makes sense, and whether this is something that helps us work on the project, or in fact it does something opposite. This presentation is totally new stuff. It's the first time I'm presenting it publicly, so I'll appreciate any feedback after the presentation, especially when you would like to hit the red button. Hit it, but just come over to me and say what you didn't like. It will help me. I've seen Fight Club yesterday, but it has no relation to feedback. You can punch me. I would really appreciate that. That will help me kind of deliver it next time better. So I'll find yourself as a beta testers. Who am I? I do lots of stuff in multiple companies, do a little bit of architecture, coding, training, and so on, but it doesn't really matter. So the question is what we are actually doing in the projects. I think we are kind of wrapping around from time to time, because it works that we get a bunch of documentation in the beginning, and changes in the documentation, so even more documents. And those documents usually go without any tracking, so we see another 100 pages and yet another 100 pages, and we have no idea what are the differences. And then we change it. We change the project one after another, get some tedious data migration because it works here, it doesn't work there. And we just usually shove it up to another developer or wait somebody else. And it just is totally outside of a typical workflow or the typical flow that the developers have. Because how we would like to work on the daily basis is pretty much git flow all the things. And the flow outside the code that we are writing is so outside of our comfort zone, and it's so outside of what we usually do, that we either don't want to pay attention to that, or paying attention to that makes us feel really painful. So what are those things? Let's talk documentation. We all love it. My former teacher at the university said that developers are paid for writing docs, because writing code is a pleasure. So we have the tooling for the documentation. We usually get business requirements in Excel spreadsheet. I have a theory about it. Business tends to put it in an Excel spreadsheet because it provides a table out of the box. And then if we are lucky and we have an architect on the project, he puts the business requirements into Enterprise Architect. Enterprise Architect is a tool. And then it ends out of the Confluence with some generated HTMLs out of it in a totally different structure. And if we try to visualize it, which you usually can find on a different website, you can see, for example, how SoundCloud does it. This whole workflow, even though it's a little bit hipster with all the cloud environments, it goes through multiple silos environments, like docs are stored here, the project tasks are stored here, but are tracked in the other tool, and then it goes to the GitHub anyway. The question is what really struggled me at some point. If we do documentation and we write those docs for the projects, who are we actually writing those documents for? And who is the kind of a stakeholder for the documentation part of the project? So I've seen that there are not one of those. There are product owners who help us writing it. They are interested in, understanding how their business requirements or functional requirements are covered by tests, are covered by the projects. There's this architect person on the project who really tries to grasp, usually from the docs, how we can govern the whole solution. There's a project manager and a team leader who is interested in getting new people on board and be able to source the project quickly and put new people on the project and get them read the documentation and have all the knowledge. And we have developers. And it appears that developers are the most is the biggest group of the stakeholders. Most of people who are reading documentation, who are working with documentation, are developers. But unfortunately, whatever we do with the documentation is totally against the work that developers usually would like to do. So the question is, what is so wrong about it? And I'll show you two examples. This is a typical functional description document that you usually probably get on your project. This is a version 0.1. It just has 155 pages. And then you got another proposal, version 0.3. A slide description of changes. It has 85 pages. So, you look at it like, where are those 70 pages? Because there are no diffs, nothing is traceable. If it's put against, traceability in Word document, it will just make it totally unreadable. It's outside of our flow. Somebody showed it up through an email. We have to version it manually, usually by adding some suffix to the document. And if we miss something, there's no way to find out who put anything to the project, to the document, and when. We don't have a git blame or SVN blame to see who changed what in the document. When I looked at the document workflow in one of our recent projects, it looked pretty much like this. Oh, it's not showing completely. So we had the Excel spreadsheet and Enterprise Architect, and it ended up in Word document, which was added again to Confluence, with some mockups added to Confluence, and some generated HTML documentation added in the Confluence, and so on and so forth. It just made everything unreadable, unmaintainable, and untraceable. We just spread documentation among different systems, and it was really hard to figure out, what was changing when and who was changing it. That was definitely not going in a good direction. So, if I were to think why it is happening like this, I found out, this will be hard diagram, there is an IEEE definition of architecture, and it's spread out to multiple disciplines, but what we focus on is covering the architecture description, just describing the projects, because that's what architects do, they describe the project. And we tend to put definitely too much in there. We put too much in the documents, while we should focus, in my opinion, on some principles, on some, for example, how the API should be documented, of some policies, how the project should be running, on defining the context, how different projects interact with each other, but then leave quite a lot, and then yes, we can put it in the Word document, but then leave as much as possible outside of the Word document, because this will change in a totally different pace than our so-called architecture. Because if you think how those things should interact with each other and how they should be changing, in my opinion, the architecture of the project, so the principles, the big ideas we have around the project, should change together with the business objective, with the business requirements of the project. So if the business changes, the architecture changes. But if the business doesn't change, all the descriptions should stay the same. And we end up in a situation that we have same business objectives, same business requirements, but we constantly change and tune the documentation in a totally different workflow of the than most people working on the project. Because what I found is we don't have this distinction between architecture and design, and we put everything in a single document. Because hardly ever, in my opinion, hardly ever in the early process and early in the project, we have a concrete, let's say, container view from the C4 model, or we do the design in such a detail that everybody knows what will follow. We are still rather in a form that we don't know, but we tend to put it in a document that makes all the changes later very hard to follow. And I think that that should change. We should shift it, and we should go closer to something that I called design as code, because all the design elements of the project can be easily put into the source code, into the Git repository, and be addressed in exactly the same way as we work with code. Because what we are actually looking forward is to avoid a situation where this kind of design document or this kind of mapping, which shows how certain endpoints are mapped against different services within the project, in the design document looked like this. So we would like to avoid a situation when a very simple flow in the design document, which we are reading up front, ends up in a totally convoluted workflow within the document, within the project. So if we go for this notion of design as code, we can think how we can document it better, how we can document our design decisions, our design processes in a way that it is maybe done by developers or done in such a way that each and every developers on the team can see those changes in exactly the same way he or she sees the changes done by other developers. So if I go again into these design as code and think about, you know, entity control boundary idea as a most pervasive architectural pattern, then I can see that each and every step within this design element can be actually derived exactly from code, and I don't need any design documents, and I don't need any Word documents to document it, because ultimately the code will be the only truth that I will be following, and everything about the document, about the project, about the product will be in the source code, and I just need a way to get it out from there and make it readable by all the other stakeholders on the project. So if I go and I say that yes, nearly on problem, you can abstract to those three terms, then you have the entity, which is the application model. These are these are simply POJOs or domain or database schemas, and we know ways to visualize it and describe it directly from code from ages, and we have been doing it ever since. Then we have the control, so descriptions of how business processes works or how documentation flow works, and then we can again describe it in a very lightweight markup languages that we can put again into code, and there's not a problem with that. And if our business say, but we need it to store it somewhere, or we needed to send it out to somebody, yes, you can make out a PDF document out of it, or a Word document out of it ultimately. And then you have your boundary, your endpoints definition. And again, that can be just Swagger documentation that you generate out of your code. So ultimately, what's in your source code and what's in your repository becomes the ultimate truth. So while the POJOs and generating the UML models out of code is pretty basic, I will cover a bit on those two things. So we get Swagger. Who is not using Swagger in here? Okay, quite a few people. I thought it's kind of becoming a standard at the moment, but I'll cover it a bit. So Swagger is a way to define or describe the REST API interfaces in a totally language agnostic way. Back in the earlier days, we have the WSDLs documents, the web services description language, yes, that covers everything, how our endpoints look like, what were the methods, what were the endpoints. But then we decided to, well, let's do it in a more lightweight way and define REST APIs and show JSON through it. But then we figure out there is no easy way to describe it. And that's where Swagger comes into it for help. So with Swagger, you can have two approaches. You have a top-down approach and bottom-up approach. So with a top-down, you can use the editor, build a YAM file, and define how your REST API will look like. And then with the code generation, generate your server-side implementation with it. Not only Java, but also different other languages like Ruby or Node.js or whatever you like. But what I favor is the different approach, the bottom-up, where you build up the documentation exactly from the REST API which we are having. And even though it might look a little bit tedious when you look into the source code, it's actually very helpful, because this is how a single method described with Swagger looks like. I consciously put additional kind of package names into the annotation, so we can see that we are adding a set of annotations to the code which actually describes what this method does. And whenever it changes, or whenever somebody decides to change it, we just get it to review as a single pull request within the code. And we totally stay in the same exact zone where we just not only review the code, but we also start reviewing documentation. And if we have something like this, or this YAML document, which is pretty much one-to-one mapping to this code, then with Swagger, we can generate HTML documents out of it, or kind of browsable HTML documents out of it, that will just cover the description of our REST API. So we have first point ticked, that we get the documentation exactly out of the code, and no more tedious Word documents describing each and every endpoint, or even worse, that was what one happened on one of our projects, that we get the REST API described in an Excel spreadsheet. You can do this. That's one part of the story. The other is that gives us the one end of the project covered, the boundaries. We have the APIs. We know what the data is coming into the module, into the service. And we obviously have the entities. We have the model visualize how it's working, how it's kind of stored in the data store, or what is the model underneath the service. What we are still lacking is a way to describe what the service actually does in a way that we can again put it into source code. It is very text-based, it's lightweight, it's not in another silo like a Word document on the enterprise architect. So what I'm using for that is an ASCII doc or ASCII doctor. ASCII doc is a syntax. It's something like Markdown, kind of, sort of, but it's far more completed than Markdown. Who has been working with Markdown, has been doing some documents with Markdown? Yes. How are you setting image properties like width in Markdown? Exactly. And in ASCII-Doc, it's far more complete in that terms. It gives you a quite complete schema how to write the document. It's yes, it's like Markdown, but much better. And there is ASCII Doctor, which is a tooling, which is a parser and on set of tools that allows you to really get your documentation into the normal flow. I'll show you in examples in a second. So ASCII Doctor covers editing the document, reading it, for example, visualizing it or rendering the previews, versioning through any source control, sharing it, because it gets you out of the box a certain tooling for building up PDFs or building up Word-like documents, not a problem, and converting it to any other format. So there is even a tooling that can give you ASCII Doctor Confluence, and you can put your ASCII Doctor document straight to the Confluence, if that's your use case. And you can integrate easily to your ordinary flow, like Git flow, and you can have it done through Jenkins jobs. That makes you really not think about updating multiple documents, updating multiple things, but you just focus on single thing that is in your source code. Because this is how ASCII Doctor actually looks like. It is a fairly lightweight schema. You just annotate different elements with some small markups, like this equal sign, or this is a source code, or you can do some marking, and then it gets rendered into more or less this HTML. So you get it in your source code, you work it as a source code, you get pretty much your documentation as source, you store it in your repository, and if needed, you just get an appropriate visualization out of it. So you kind of compile it for your business. And that way, we get to no more Word design documents. Woohoo! Now let's talk operations. That was the part of the story. Yes. Yes, there's a part of the tooling that is called ASCII Doctor diagram. So if you describe your kind of design or the service with a text, it's fine. But if you would like to add some flow diagramming or some data diagrams or whatever, you can still do it in Plant UML, for example. Who knows Plant UML? Yeah, a few. That's a very hipster technology. So you can do your diagrams in plain text, and then ASCII Doctors get it rendered into the images on fly. So you have not only your source code readable, but also all the diagrams are S code, and then you don't focus on the visualization, on the pixel perfectness of your diagram. You just put the information there, and make it available for everybody. There are other things in ASCII Doctor environment, like Jarek Pałka was yesterday using the MathML plugin. So you put MathML equations into your ASCII Doctor document, and then it gets rendered as a proper MathML formulae. So a very powerful tooling, worth looking into it. That's kind of the entry for the projects. We describe how we are working with things. Now let's talk operations. So we get our requirements, we get describe what we are building, we are actually building it, and then we are showing it to the other side of the company to let it run. Who's having an actually operations department in the company? Like guys who you need to put stuff into a different part of the world. Yeah, so do I. The DevOps is a nice term, but hardly anybody is using it in a bigger company. So if you think about the operation scope, at least that's how it's working in an environment that I'm working on a daily basis. The operations are looking for infrastructure. They're looking for applications deployments. They are looking for data migrations and monitoring. That's their scope. That's what they do. And then they try to optimize their workflow, so they have to talk as little as possible with anybody else outside. So with our operations, our language, our communication language consists of two elements. It's SVN app. That's how I give them application. And they do SVN app and it's deployed. And they have a second mem in head, which is DB init. That's how they migrate databases. And that's, for example, how it's working in our world. I don't say it's good or in any way or positive, but that gives you to another thing. There is something called people per server ratio in such operation environment. And on average, in our case, there's, well, in general in IT, a healthy formula for operations, it's one technician, one operations engineer per 200 to 500 servers. That's how many servers they can cover. In our case, in our company, it's from 100 to 250, depending how you count. But then the Facebook guys came over and say, yeah, that's nice, but in Facebook, one technician is covering 25,000 servers. Eat this. So if you see that's not an order of magnitude, but 2 orders of magnitude difference, then you generally see that the way operations at the moment works is just not efficient. Even they're efficient within their silo, it's not efficient in general, and you can just do it better. So one of the way to do it better will be to automate everything. And if we start automating everything, then why not put it in the source code and treat it exactly as source and let both developers and operations guy collaborate on it. So just get through all the things. So what we are trying to do, I'm not saying we are already successful with that. We are trying to set up some principles. So every step of the delivery is a Jenkins job. Jenkins is not an ideal tool, but it's pretty damn good in automation things. And the deployments are rolling forward only. So no logging to servers, hands-off policy. So if I break something, I create a new instance of the image, of the virtual image, and just roll it forward and forward and forward until it's fixed. Because that brings us towards maybe not virtualization, but hardly ever we are working on physical machines at the moment. We have all those layers of virtualization on the top of it. And if we are building a virtual containers or virtual images, we can do it through scripting, and we can do it through some configuration, text-based files, JSONs, whatsoever. And we should, again, be storing that in source code. We can find the best tool for this job. Yes, if we are hipster, and we can use Docker, or we can just go the more classic way and have a classic approach towards automation of the provisioning with Puppet or Chef or Ansible, whichever you like. And with Packer IO, just prepare the bare image. So I'll show you how it might look like. Who's using Docker on daily basis? Whoa, 3 people, 4 people. Who is using Docker on production? Slightly less. So when you go with containers, you actually put your app in the container. Container is a lightweight operating system for the application, let's call it like this. And you define it. You just build a script that defines certain steps that let you prepare the application. With Docker, it looks like this, that you have a Docker file. And to run a Java application within the Docker, not that's a very good idea in general, but you can do this. You define 3 steps, more or less. You define the base image, which is this from. Docker supports multiple layering of images. So you take a baseline operating system, like say Debian, Ubuntu, what you like. Windows is not supported, but that's yet. And then you build a few layers on the top of it, and you just name it, and then you can use it again for some other tooling and so on. So we have a baseline image, which is a Java environment, which is actually a Linux environment with Java runtime environment installed onto it. We are using Java 8. And then we copy what we have in our Maven folder on the project, and define that if somebody will run this image, this is the command that will be actually running. So what we'll do is we'll just do java -jar for our Spring Boot application, for example. And then we just build an image and run it, and we have it up and running. And if we store this small text file document within the project, then again, any change in the environment, any change within the infrastructure is just visible. It's just provided out of the box, and there is no magic that you get this farm of 6 servers, and this is a set story, and each and every server is just configured differently because it was delivered by different technicians. So you just get a standard which are transparent, you just get it, describe how it actually is, and what you also gain is you have actually the same stuff in your production environment, in your testing environment, in your staging environment, and as your development tooling. That's really nice. If for any reason you don't want to have it as a Docker file, because you would like to have it like Maven running natively on your Jenkins, you can obviously put it in a more verbose way through Maven POM file. So you can pretty much do exactly the same as here with your Maven. So then you can have the Jenkins environment, building your image and deploying your image in exactly the same way, and it's deploying your artifacts. Obviously, if you are not in a very if you are more into legacy environment, whereas containers is in a way, and your operations guy have no interest in listening to your old Docker stories, you can do exactly the same without containers. If you don't have containers, but you still have a virtualization environments, then you are still not working with a bare metal, but you have a certain VM on top of it. Depending where you go, if you're going into the cloud, you can have Amazon Web Services as the baseline. You can have your own so-called private cloud based on Xen or whatever. You can just use virtual boxes for your development environments. It doesn't really matter. There are tooling that lets you build images on the top of it fairly easily, and I will cover them a bit. Who has heard of Pucker? Again, a few people. Pucker is a tool that, in my opinion, addresses 2 things. It gives you this dev to production parity, so it gives you a single script, a single recipe for the environment, and it can be either development or staging or test on production, and in all the cases is as similar as possible. You ultimately use a single recipe to build it, and then you build this environment from a template. So you generate a virtual image out of a JSON file that prescribes what exactly is built on this virtual machine. So, in my opinion, what Pucker gives is it covers 2 important gaps. It covers the so-called personal gap that usually on our projects we had developers maintaining the development environments, sometimes shared development environments, but still developers. And then we had operations that were keeping an eye on the production and on the testing environments. And what I've seen usually was so-called tools gap, that we have a different ecosystem on production and different ecosystems on development environments. Probably most of us run into situations that on production environments we were actually using Apache, while on dev we were using Nginx, or we had JBoss or JBoss 4 something patch on production, but still on the development environments we are using some lightweight containers. Or we had this Apache Tomcat versus Jetty thing, or different databases, or Oracle here, but not Oracle, or Oracle Express on the development environments. And yes, that's again problematic. So with Packer, we have this idea that we have a single template that allows us to build an environment, and no matter whether it's a production or test environment, it's always the same. And the Packer template that actually builds the environment consists of three important elements: builders, post-processors, and provisioners. So it gives you an ability to define your image with a builder, like the VM configuration. This is how much memory I would like to get. These are the drives. This is the network interfaces I would like to have it in there. Then in post-processor, you say, okay, you've built it, and now clean it up and compress and do something with it. And provisioners, so usually shell script, because these are scripts in the language of the virtual machine that you've built that allows you to do some post-processing configuration on the machine, like do the apt-get update or install Puppet with the apt-get comment. So you put it in there, and this is pretty much how it looks. How it might look in the JSON file. So you have those sections explicit. You have builders. You have post-processors. You have provisioners, which are some scripts that are run after the build process. And then whatever happens in the project, when somebody decides that, well, we need more CPUs, or we need more memory on the machine, you get it explicitly in here. And then on the top of it, you can use your favorite provisioning tool to just install whatever you need on the application. The VM is the baseline, and then you can put things on the top of it. And the thing is, depending on what you need and how your workflow looks like, you can do it differently. For example, in one of the projects that I've been into, we had a simple web service that Packer was installing on each and every machine, and this web service was just a way for our Jenkins to communicate with the newly deployed virtual machine to so-called tell them, provision yourself. And we're just passing an argument that this is going to be a Java application server virtual machine, and the script was pulling the appropriate in that terms Puppet manifests, and just do the provisioning of everything that was needed for this application server machine to work. And then we had another Jenkins job to just provision the application, pretty much deploy the thing. And that pretty much covers the important things of the operation scope, so infrastructure and application deployment. And again, there are tools that you can put it inside the source code and just have it visible. What we also missed is database migration. Then obviously there are other tools for that. There is something called Flyway, who has been using either Liquidbase or Flyway. The software mill guys are very hip. Well, good for you. With Flyway, what you can do is you can have additional tooling that will help you do and cover the migrations of the of your database schema. Where I'm missing, while I'm talking about Flyway, not Liquidbase, because there are two kind of important tooling in that area. I like Flyway because it doesn't cheat itself that it can be database independent. It just says that SQL scripts are my first-class citizens, and I am just running that. So there is no tedious XML to abstract your database schema. It's just SQL that you run. And what Flyway does, it helps you manage the migration of your environment. So you put some SQL scripts in your project. For example, create person table and add people, and then with Flyway migrate, it just walks through the SQL folder in your project and runs the migration one by one, and that makes it up to date on the environment. Internally, how Flyway works is it creates itself a metadata table called schema version. If it doesn't exist, if it exists, it uses it. And it applies all the migrations ordered by the version number. And what you can see is that it has the history of everything that has been run on your production environment or on any environment with your scripts. So that's another way to have all the changes and all the migrations explicit within your project, within your source code documentations. I remember at one of the projects, what we were doing is we were having an A4 checklist, like do these steps on those multiple servers, and we stored it in just different places in the text documents, just to remember what actually was changed through the projects on the environment. And with those tooling, I just have it in my source code as a set of configuration files, which I can version, and I can diff one and another to see what were the changes. So this gives us pretty much a complete scope of how at least our operations were working. So infrastructure, deployment, and the data migrations, that is all in source code. The monitoring is a totally different thing. So in my opinion, it gives kind of a operation sanity, and I can work with them. So now let's talk testers. That's a final step, a quick one. So I worked for a while in this environment that was tester-driven development. So we had testers guys, and we were just showing source code to them, and then they were pretty much checking if everything was working, and that wasn't very effective, because what I seen is that we make much better use of people, so-called testers, when we define the QA as not only quality assurance, but also quality analysts or quality ambassadors, where testers' role is not only to check whether the code is actually doing, but also do some proactive process or awareness things to have it working. And in many cases, it ends up that the QA guys are doing some automations, are doing some human readable scripts that we can run on the environment and actually see whether the application is doing what it's supposed to be doing. But then it has been all covered, because the test cases can be treated as code, and the test data can be treated as code, and the configuration can be treated as code, and you can put everything into your source code. So what you can do is just do it. A small pointer. There's two final slides, because I'm kind of extending my 40 minutes, but as I told you at the beginning, it's first time, so I still need to adjust. We got tools. In my opinion, we got everything that is possible to build the tooling around our projects, where we can treat not only source code as code, but also any other artifacts around in a similar way. But that is hard. That will be hard to do, because we have to crunch some walls. We'll have to move certain environments that are usually not talking to each other, just work together on the project. It's not easy. You have to, for example, shift from perspective that architecture is about design. No, it's not about design, it's about documenting the decisions, about, empowering a team to work in a certain way. That operations are not about deploying, or more, we need to get into the notion of you code it, you deploy it. And in my opinion, you have to get rid of enterprise architect, because it's neither enterprise nor architect. And then finally, if we crunch those walls, we have to change the organization, and that's the hardest part. Because what you've seen, the tooling, is the easy part. That's kind of our comfort zone. But now we have the hard time of changing how we work with people. So thank you very much. Do you have any questions?